welcome to Chapter 4 Geometry Part 1. Our objectives are: recall and use the properties of sides, midline, remarkable lines in triangles. Recall and apply the properties of a right triangle. Recall about central and axial symmetry. Recall about quadrilaterals and special parallelograms. These are the materials you should prepare before you start. From the previous year, you know that if two lines D1 and D2 are parallel and they are cut by a transversal D, then interior angles on the same side of a transversal are formed. A1 and B1 are supplementary angles. Their sum is equal to 180 degrees. Also, alternate interior angles and corresponding angles are formed. Angle A1 and angle B1 make the shape of C. They are called alternate interior angles and they are equal. Angles A2 and B2 make the shape of MF and also they are equal. They are called corresponding angles. Conversely, if two alternating or corresponding angles formed by two lines and a transversal are equal, then these two lines are parallel. Let's start with remarkable lines in a triangle. First, the medians in a triangle meet at a point called center of gravity or centroid, which divides each median to the ratio 2/3 starting from the vertex. Example: in triangle IKJ, the three medians intersect at point G. G is a point of the median IL, so it divides it to the ratio 2/3 starting from its vertex I. This means that GL will be equal to 1/3 of the median IL, GI will be equal to 2/3 of the median IL, and GL is equal to half of GI. To show that a point G is the centroid of a triangle, either you show that it is the intersection of two medians or you show that it is a point of a median and it divides this median to the ratio 2/3 starting from the vertex. This is an application. Please read it carefully, pause the video, then come to see the solution after you solve it alone. Here we want to find the ratio GL over LI. GL is equal to LI minus IG, 4.5 minus 1.5 equal to 3. Over LI, which is 4.5, you get 2/3. Then we say that Li is a median, G is a point of this median that divides it to the ratio 2/3 starting from its vertex L, so G is the centroid of triangle FEL. Part 2, we want to prove that FG cuts EL at its midpoint. We know that FG is drawn from the vertex, passes through the centroid, so it is the second median, so FG cuts EL at its midpoint. Second, we have the heights in a triangle. Also, the heights meet at a point, at one point called orthocenter. In triangle GEF, we have the three heights. They intersect at point O. The orthocenter in the case of an acute triangle is inside the triangle. If the triangle is right, the orthocenter is the vertex of the right angle. Example: in triangle MNP, we have the two heights MH and NK intersect at Q, then Q is the orthocenter of triangle MNP. Now, if we take the obtuse triangle MQM, in the obtuse triangle MQM, we have MK and MH are perpendicular to MQ and MQ respectively. So, MK and MH are the heights in triangle MQM, but these heights intersect outside the triangle. They intersect at point P. In an obtuse triangle, the orthocenter is outside the triangle. The perpendicular bisectors of the sides of a triangle meet at a point called circumcenter. It is the center of the circle circumscribed about the triangle. This means the circle that passes through the three vertices of the triangle. In case of right triangle, this is a special case, the circumcenter will be the midpoint of the hypotenuse. In a triangle also we have three angles, their bisectors meet in a point called incenter. It is the center of the circle inscribed inside that triangle, which is tangent to the three sides of the triangle. A very important theorem in a triangle is the midpoint theorem. It states that the line segment joining the midpoint of two sides of a triangle is parallel to the third side and equals half of it. Example, in triangle ABC here, M is the midpoint of AB and N is the midpoint of AC. Then by midpoint theorem, MN will be parallel to BC and MN is equal to BC over 2. Conversely, the parallel drawn from the midpoint of one side to another side of the triangle cuts the third side at its midpoint. Example, in triangle ABC here, we have M given midpoint of AB. MN is drawn parallel to BC. Then, by converse of midpoint theorem, N will be the midpoint of AC. Recall about right triangle and circle. Any point on the circumference of a circle makes an angle 90 degrees with the diameter. Example, C is a circle with diameter AB. M is a point on the circle. Then the angle AMB is equal to 90 degrees because it is an inscribed angle facing the diameter. So triangle AMB will be right at M. This is an application. Read it carefully, pause the video, try to solve it alone, then come to discuss the solution. We want to show that OE is perpendicular to KJ. First, we have O is the midpoint of IJ because O is the center of the circle. E is the midpoint of KJ given. Then by midpoint theorem, in triangle IJK, we have OE is parallel to IK. Moreover, we have the angle IKJ is equal to 90 degrees because it is an inscribed angle facing diameter. So the angle OEJ is also equal to 90 degrees because these two angles are corresponding angles. They make the shape of F formed by these two parallel lines IK and OE. So OE will be perpendicular to KJ. Right triangle and median relative to the hypotenuse. In a right triangle, the median segment relative to the hypotenuse is equal to half the hypotenuse. Example, in triangle ABC, AM is median relative to hypotenuse BC. Then AM is equal to BC over 2. Conversely, if the median segment is equal to half the opposite side, then the triangle is right. Example, triangle IKJ, given IM is median relative to KJ, and also given that IM is equal to KM equal to MJ, this means IM is equal to KJ over 2. So triangle KIJ will be right at R. This is an application. Please try to solve it alone. Pause the video, take your time to solve it, then come to see the solution. We want to show that triangle AOF is right. In triangle AOF, we have AI is median because I is the midpoint of FO by symmetry. And AI is equal to 2 cm given. IO is equal to the radius of the circle 2 cm. So AI is equal to OF over 2. And AI is median relative to OF, so triangle is right. Right triangle and Pythagoras theorem. Pythagoras theorem is a theorem that helps us to find the missing length of a certain side in a right triangle. It states that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the square of the two other sides. Example, in triangle EGF, you have the lengths of EF and EG. You can find the length of FG by applying Pythagoras because it is a right triangle at E. FG squared is equal to EF squared plus EG squared, which is equal to 20. Then FG is equal to a radical 20, which is equal to 2 radical 5. Conversely, if in a triangle ABC we have BC squared is equal to AB squared plus AC squared, then the triangle ABC will be right at A. Example, suppose in this triangle we have AB is equal to radical 2, AC is equal to 3, and BC is equal to radical 11. To show that the triangle ABC is right, we can find BC squared, which is equal to radical 11 squared equal to 11. And we start with the longest side and make it square. Then we find AB squared plus AC squared is equal to 2 plus 9, which is also equal to 11, so it is equal to BC squared. So by converse of Pythagoras theorem, triangle ABC is right at A. Also, please take your time to read the application, pause the video, solve it alone, then come to see the solution. In triangle EFD, we want to find ED, the length of ED. So we apply Pythagoras theorem because we have the lengths of two other sides. We say that FD squared, we start with FD because it is the hypotenuse, FD squared is equal to EF squared plus ED squared. Then by calculation, ED will be equal to 5. In part 2, we want to show that EDG is a right triangle. We say that now we have the length of ED, which is equal to 5. So in this triangle, we have the lengths of its three sides. If we try to apply the converse of Pythagoras, we see that EG squared plus GD squared is equal to 25, and also ED squared is equal to 25. Then by the converse of Pythagoras theorem, triangle EDG is right at G. Let's recall axial and central symmetry. A point M is the symmetric of N with respect to a line D if the line D is the perpendicular bisector of MN. This is axial symmetry with respect to a line. A point M is the symmetric of M with respect to a point E if E is the midpoint of MN. This is central symmetry or symmetry with respect to a point. Quadrilaterals. First, a trapezoid is a quadrilateral that has exactly two opposite sides are parallel, AB parallel to DC, AD and BC not parallel, they are the legs. Trapezoid plus one right angle, it is a right trapezoid. Also, if you have a trapezoid plus one of these properties, additional properties, non-parallel sides are equal, AD is equal to BC, or we have diagonals are equal, AC is equal to BD, or we have angles at a base are equal, A equal to B or B equal to C, then this trapezoid will be an isosceles trapezoid. Recall about parallelograms and special parallelograms. To prove that a quadrilateral is a parallelogram, it is sufficient to prove one of the following. The opposite sides are parallel, the opposite sides are equal, two opposite sides are equal and parallel, the diagonals bisect each other. Ways to prove a rectangle. It has three right angles. It is a parallelogram with one right angle. It is a parallelogram with diagonals are equal. Ways to show a rhombus. The four sides are equal. It is a parallelogram with two equal adjacent sides. It is a parallelogram with diagonals are perpendicular. Finally, to show that a quadrilateral is a square, you can use one of the ways. It has four equal sides and three right angles. It is a rectangle with two equal adjacent or consecutive sides. It is a rhombus with one right angle. As an assignment, please review pages 51 to 63 from the textbook and do as a homework exercise 1 on extra sheet. This is a summary. Please study it very well. It is a recall for all the important properties in the video. That was all for today. Thank you for watching.